Hello everyone, good evening. I welcome you all for today's live session. All the children who are joining us for the first time, who are joining our live session for the first time, let me just quickly introduce myself. This is Neha Chauhan here. I am a subject matter expert at Cuemath and I will be the host. That is, I'll be conducting the live session for today. So, do you all know what is the topic for today's live session? How many of you know what is the topic for today's live session? You all can quickly comment that in the chat box and tell us what is the topic for today's live session if you know. All right, so let's see how many students know what is the topic for today. And these are for some particular grades, but you can also be joining your particular grade's live session as per the calendar. So we'll talk about that a little later. Now, let's just see for all the students who do not know what's the topic for today's live session. The topic for today's live session is factors, multiples, and primes. So we'll be starting very shortly. We'll just wait for a few more minutes and then we will start with today's live session. All right, all. Now that all of you know what the topic for today is, it's factors, multiples, and primes. So here we will be beginning with our today's live session. So we'll be learning some core basics of what factors are, multiples are, and what primes are. We'll not go in much of depth and in much of detail because that's a vast topic in itself. So we would be learning some core basics of what factors, multiples, and primes are. Now, just to know, just to let you all know about these live sessions. So we at Cuemath are providing live sessions which are absolutely free, and these are the free live interactive classes, and they come across grades of K to 8, and these are conducted on an average thrice a week. That is 3 times a week. You will be having these interactive live sessions. Also, a particular calendar gets shared about these live classes, the weekly calendar, in the WhatsApp group, wherein you all are a part of. And for those of you who are not, you can join in that WhatsApp group. So basically, the calendar will tell you, what does it give you? It gives you the information of the topics on which the live sessions would be held. Also, which grade relevant those topics are. Like for today, that we're doing factors, multiples, and prime. This topic we are particularly targeting, for children who are in grade 4, 5, and 6. But it's absolutely fine if other children are also joining us. For younger children, it might be something new that you all would be learning today. And for children who are in higher grades than grade 4, 5, 6, would be like a quick revision of, the concept which you have already studied. And if at all, if you have any doubts, you can definitely take this as a revision class. So it's absolutely free that you all be a part of all the master classes, all the live classes which happen. But in case you're very particular in attending only the classes which are your grade relevant, do follow the weekly calendar that gets shared in the WhatsApp group. So now we'll start with the very first, out of the three, we had factors, multiples, and we had primes. So we'll start with multiples because if we were to trace back what we have learned in mathematics so far, we start with something very basic as knowing numbers. Once we know numbers, then we learn some very basic operations of addition and subtraction. And right after addition and subtraction, what comes is multiplication. Now, multiples are very closely related to multiplication. Okay, so that's why we are taking multiple first, and let's see what multiples are. So do you all know what multiples are? Like any of the children like who know what multiples are? You can always write your answers in the chat box, and we'll see who all are the children who are quite active. Also, if during the live session, if you feel that you have any doubts anywhere, please put it in the chat box and we'll pick it up from there, and we'll definitely be reverting to those queries and doubts. All right, so let's learn multiples. Let's not go by definition of it because that's what you've been learning in your classes and in your tuition classes. Let's learn through, the multiplication tables. Let's learn through examples. So what you see on your screen is the multiplication table of 3. Like we start learning from the multiplication table of 2, 3, 4, 5, and it's very important to for younger children to at least know multiplication tables till 9. So how it goes like 3 ones are 3, 3 twos are 6, 3 threes are 9, 3 fours are 12, so on, so till 3 tens are 30. You can go even beyond that, but like multiplication tables are only learned till 10. Okay, so now where are multiples associated here, like where are they closely, when I said these are very closely associated with multiplication tables, so where exactly do we have multiples? So if you would look at all the numbers to the rightmost side, that is towards the right side of the equal to symbol, that is 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Okay, so these are all called as the non-zero multiples of 3. Now why non-zero? 0 is also a multiple of 3, because 3 times 0, if you would do, you get the answer as 0. But here, are we starting with 0? We aren't. So starting with 3 and going beyond, all what you see in this multiplication table are the non-zero multiples of 3. So here we get the definition of what multiples are. It's the product of a number with another number. Okay, so here what we are seeing is these are all the multiples of 3. You can go even beyond 10. You can then write 3 times 11, which is 33, and that also is a multiple of 3. So did you all understand? 33 is the multiple. These are all, like, which are highlighted in the box written in purple. These are all the multiples of 3, because they are the products of 3 with another number. That number could be anything. Okay, so you have n number of multiples. It doesn't really end anywhere. It starts with 0 and goes on till infinity. There's no ending to the multiples of any number. So I hope this is clear with all of you to understand what non-zero multiples, and even if you were to say 0 as the multiple of any number. If at all, if you have any doubts, please do put it in the chat box. Now coming to a point where we need to understand or identify whether a number is a multiple of another number or not. Now let's just take from this same table. If I was to ask you, is 12 a multiple of 3? As we can definitely spot it in the multiplication table of 3, we would say, yes, it is. 12 is a multiple of 3. But can we do that, in every case? What if the number is really very huge? Let's say the number is 1324, 1324. Now you need to tell me whether 1324 is a multiple of 3 or not. Is this a multiple of 3? Now, how would you do it? Another way of identifying whether a certain number is a multiple of another number is by dividing it by the number for which you're looking, for which it has to be a multiple. So here we are looking whether this is a multiple of 3 or not. So I would be dividing it by 3. So we'll go with the first 2 digits here, which is 13. So 3 fours are 12. When we subtract, we get 1. We would take down 2. Now 3 fours are 12 again. We subtract, we get 0. We will take down 4. Now 3 ones are 3. When we subtract, we get 1. Can we do the division further? We cannot, because now 1, which is the dividend, is lesser than the divisor, which is 3. So we cannot take our division, ahead of it. So here our division ends. So we have gotten a remainder which is not 0. Now in any case wherein on division you do not get the remainder as 0, that means the given number is not a multiple of the number for which you were trying to identify whether it's a multiple or not. So here we would say that 1324 is not a multiple of 3. It's not a multiple of 3. Why? Because on division we did not get the answer or the remainder as 0. So there are two ways of identifying whether a number is a multiple of another number. One way is to go with the multiplication table. If the number is really small, you can check it in the multiplication table. Another way of doing it is you do the division. If you get the remainder 0, that means it is yes, a multiple. If the remainder is not 0, then no, it's not a multiple. So now that we have understood the whole concept of what multiples are, what non-zero multiples are, 0 is also a multiple. So, and also we have seen whether how to identify whether a number is a multiple or not of another number. We'll try out some questions, okay? So here goes the first question on screen. So all of you who are really very excited, you can grab, like if you've already grabbed a pen and a paper, you can quickly start answering these questions and put your answers in the chat box. So here's the question for you. Is 279 a multiple of 3? All you have to do is to check whether 279 is a multiple of 3. Now, there are two ways of doing it. You either go with the multiplication table or you can go with the division. Because the multiplication table of 3, what we have learned, ends at 30. 3 tens are 30. I think the first one would not work. You all can go for division and check whether the remainder is coming 0 or not. So quickly, I'll just answer it as yes or no, whether 279 is a multiple of 3 or not. Okay, so we'll try to figure out the answer for this. So 279 is what we are checking, whether it is a multiple of 3 or not. So we'll divide 279 by 3. Okay, so we go in with the first two digits. So 27, so 3 nines are 27. On subtracting, we get 0. We will take down 9 and 3 threes are 9. We subtract and again we get a 0 and the division ends here. So we have gotten a remainder which is 0. So yes, 279 is a multiple of 3. So did this make more sense? And I think now you'd be very, very thorough of how to identify the multiples. So we'll quickly go on to another question to try out. So now again, be ready, all of you, with your pen and paper. Here comes the question on screen. And the question is 347 a multiple of 7? So again, the number is, would not fit in the multiplication table of 7 because it ends at 70. You all can go with the division method. Try dividing 347 with 7 by 7 and see whether you're getting the answer as the remainder as 0. If that does come as 0, then that means the number 347 is a multiple. If it doesn't, that means it's not. So quickly, you all just do the division and write in your answers in the chat box whether it's a yes or no. And if at all, if you're having some trouble solving this up, and if you have any questions, please do post it. We'll pick it up and we'll revert on that. Okay, so now let me just help you all in understanding how to do it once again. So 347 is to be divided by 7. So we'll go in with the first two digits, that is 34. Now 7 fives are 35, which is bigger than 34. So we'll go with 7 fours are. The 7 fours are 28. So on subtraction, we get 6. We take down 7. Now we know that 7 nines are 63.
And on subtraction, you would get the remainder as 4.
Now we cannot take the division further because the dividend, which is
4,
is lesser than the divisor, which is 7. So all we needed to do was the division, the long division that we have done here. And we did not get the remainder as 0.
4.
Not equal to 0. The remainder is not 0. So no, the given number is not a multiple of 7. Okay, so here we have understood what multiples are. It's basically the product of one number with another number. And we've also seen how to identify it. We'll go on to the next part, which is called as factors. Okay, so again, just as multiples, I would say that factors is also something which would have already been introduced to you in your schools. But we will try to learn it in a different way. We will try to learn it through, some examples. So let's take a number first. So we're taking the number 6, okay? And we will try to find out all the factors, or which are all the factors of 6. So what I do here is I take a bar, which I say is, let's say this whole bar is representing length 6, okay? And below what you see is a scale, which is, I'll just mark it up, which is starting with 0. So this is representing 0. This is representing 1, 2, 3, 4, 5, 6. That means this entire length starting from here till here is representing 6. This whole bar is of 6 units. Now, let's just take bricks of equal length. There are 6 bricks that you see, and they're exactly fitting the same length. Okay, if you're taking identical, bricks of same length, and there are 6 bricks, they're exactly fitting the original length of 6. So what would you understand from this is, see, this is 1, 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 and this is 1. So how many blocks do you see here? 1, 2, 3, 4, 5, 6. So that means this entire rod or block could be divided identically into 6 smaller blocks. So that means 1 can be considered as a factor of 6. Now let's go in with another number right below it. So what I would do is I will take 2, like this 1 plus 1, this block is representing 2 units. Then from here till here, this block is representing 2 units again, and this block is representing 2 units again. So we can also divide the whole block or the rod of 6 units into smaller blocks of 2 units. So that would mean 2 is also a factor because it's completely fitting, not more, not less. Okay, it's completely fitting in the same length of 6 units. So 2 is also a factor of 6. Now, if we were to go with 3, okay, so 1 plus 1 plus 1 is 3. So I would basically be going from here till here, dot, 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 dot. So somewhere it comes here. And from here till here, we can make it into, like I have drawn it roughly. So it basically representing 3 units each and is perfectly fitting the length of 6 units. Now, if I go in with 4, which comes somewhere here, I'll just draw it. 4 comes here. Okay, so this block entirely is representing 4. Now another block which has got a length of 4 would exceed 6, would go beyond 6, So it's not exactly fitting the length of 6. So that means 4 is not a factor of 6. And then definitely 6 is the factor of, itself. So I think this would have made more sense visually to understand what factors are. So, a number which can be perfectly divided into smaller numbers, those are all the factors that you have. So that means 6 when divided by 6, you get the remainder 0. Then 6, the same number when divided by, 1, so 1 6 are 6, you again get 0. The same number 6, when you're dividing it by 2, 3s are 6, you get remainder 0. So all those numbers which when dividing 6 leave a remainder as 0 are the factors of 6. So always, in all cases, in each number's case, the smallest factor is 1 and the largest factor is the number itself. Let's say if you were to find the factors of 8, the smallest factor of 8 would always be 1 and the largest factor of 8 would be 8 itself. In between you might have more or less factors. Basically, how would you find the factors? All the numbers which perfectly divide, perfectly, or we can say the word exactly. Now what does that mean? Which leave a remainder 0. Okay, those are all the numbers those are called as the factors of a given number. So I hope you have understood what basically a multiple is and what a factor is. And there are many more properties that come along with factors and multiples. We'll not go in depth, as I had said at the start of the class, because we have limited time. So now that you've understood what factors are, we'll be trying out some questions. So all you need to do is to write all the factors of 36. Okay, I give you all some time. All you need to do is list down all the factors of 36. Make sure that you're writing down all the factors of 36. Okay, so one way of doing it is, which is really cool, is that, you can start with 1 and at the end you just simply write 36. Because as I said, for all the numbers, the smallest factor is 1 and the largest factor is the number itself. In between, you can fill in, you can go in sequence. So if you were to divide 36 by 2, you would get a remainder 0. So 2 is a factor. 36 is also perfectly divisible by 3, so 3 is also a factor. In 4's table, multiplication table, we again get 36. 4 9s are 36, so it's perfectly divisible. So 4 is a factor. 5 is not, because the last digit, like the digit at the ones place, is neither 5 or nor 0, so it's not divisible. 6 6 are 36, so 6 also is a factor. 7 is not a factor of 36, so is not 8. 9 4s are 36, so 9. 10 is not, 11 is not, 12 is a 12, 12 is a 24, 12 3s are 36, so 12 it is. 13 1s are 13, 13 2s are 26, 13 3s are 39, so 13 is not a factor, and so on. You can keep going, you can keep going and you would get all the factors of 36. So this is how you can probably be listing down all the factors of 36. So now that you have all understood what factors are, what multiples are, and we have seen some examples also, we have worked out on some problems, we'll go on to the next part, which is called as primes. Now primes is a little tricky, so just follow very closely to what I'm trying to explain. So this is in relation with what we have learned in factors. Okay, any number which has got just two factors, that is 1 and the number itself, there is no factor that you can fill in between these two. What did we see previously? That you take a number, the smallest factor is 1, the largest factor is the number itself, and in between you can fill in with some more factors. You might find on the way towards the largest factor, you might find some more factors. But any number which just has these two factors, that is 1 and the number itself, is called as a prime number. Okay, so it has to have two factors, so 1 and the number itself. So let's see some examples. Where a lot of students make a mistake is in understanding whether 1 is a prime number or not. Do we consider this as a prime number? So please do put your answers in the chat box and telling me whether 1 is a prime number or not. Now we'll start with the smallest prime number that we have. So the smallest prime number that we have is 2, because 1 is one of the factors of 2, and the next factor of 2 that we have is 2 itself. So what does that mean? Now these are the two factors of 2. So 1 is not the smallest prime number. We start with the smallest prime number, which is 2. 1 is not a prime number to answer that question, because it's got only one factor. You have to have two factors, 1 and the number itself. So 2 is the smallest prime number. Coming to 3, again, you have only two factors, which is 1 and 3. So this is also a prime number. So 2, then 3. Can you all tell me which is the next prime number in the number series after 3? After 3, the next that we have is 5. After 5, next what we have is 7, 8, 9. No, 9, a lot of students get confused with, odd, even numbers, prime numbers. So it's not with odd or even. it's about having two factors only. Okay, that is 1 and the number itself. So 9 has got 3 also as a factor, so 9 is not a prime number. So 7, 8, 9, 10, 11 is a prime number, and it keeps going. Okay, so I hope you all have understood what primes are. Now we'll go, so yeah, so only factors are 1 and the number itself. We'll go on to the next part, which is prime factorization. Now this is what I will explain you through an example. You all can quickly follow, like closely follow what I'm saying. Okay, so basically, in prime factorization, what happens is you can take any number, okay, any number, and you can always write it as a product of prime numbers. How I would tell you, let's say you have the number 342. Now when we say prime factorization, you have to start factoring the number. That means you have to start dividing the number. And as we also have the word prior to factorization, which is prime, means you only have to list the prime factors. You would not go with any other factor which is not a prime number. Okay, so we will be starting with the smallest prime number. You start from the smallest one so that you keep checking on it. So the smallest prime number is 2, and as this is an even number, it would be divisible by 2. So you divide 342 by 2, so you have 2 ones are 2, 7s are 14, and ones are 1. Okay, next you would go in and you would see which number can divide 171. So now 2 would not divide 171 because it's not an even number, so we can go in with 3. So 3 5s are 15, you're left with 2, so 7s are 21. Okay, let's see if we further divide it with 3. So 3 1s are 3, 9s are 27. Now 19 is a prime number, so you would stop it at that. You will keep doing the division this way until you get 1. So I'll just again tell you, to all the students who might not have understood in this time, see, this is always the dividend. Here what you write is always the divisor. You do the division with the prime number which perfectly divides it. You would only go in with the numbers which perfectly divide the dividend. So we took 2 as the first divisor. Whatever the quotient that you get is what is to be written here. That will become your new dividend. Then you would check for another prime number. So here another prime number that we took as the divisor was 3. On doing the division, the quotient that you get again is written below. This becomes your new dividend again, and you would check in for another divisor, and that's how you keep on doing until you get the answer as 1. So basically here what happened is 342 can be written as a product of prime numbers, which is 2 times 3 times 3 times 19. If you would see, these are all prime numbers, and 342 has been written as a product of the prime numbers. So this is called as prime factorization. Moving ahead, we have seen it all of what was the topic for today, that is factors, multiples, and prime. So we'll have some quick tests for you all. Now this is a test that you all need to answer because you all have gone through the concepts, also have gone through some example problems. So these are the problems that are to test your knowledge now of what you have understood today by, through the live session that we have had today. So the first question quickly is, which of the following are the multiples of 15? So I would be providing you some options. Whichever you feel that there might be multiple correct answers, you all have to list down all the correct answers. Okay, so it says, which of the following are the multiples of 15? So here comes your options. So these are all the options. Quickly check and tell me which are all amongst these 4 are the multiples of 15. You only have to choose which are the multiples. There might be more than 1, more than 2. Okay, I give you all some time. You can put your answers in the chat box. How would you check it? I said there are 2 ways of doing it. You either go with the multiplication table, or you can go in with the division. You can, divide each of these options and see whether you're getting the remainder as 0 or not. Or you can, read out multiplication table of 15 if at all you know. If you know the multiplication table of 15, you can definitely go with that because these are all smaller numbers. You can easily go with the multiplication table. All right. So we'll see 45. So if you would take 15 and times it with 3, so 3 fives are 15, 1 carried forward, plus 1 is 4. So 45. So it does come in the multiplication table of 15. So this is a multiple of 15. 75. If you do 15 times 5, 5 fives are 25, 2 carried forward, 5 is a 5 plus 2, 7. So yes, this also is a multiple of 15. 85. Now 15 fives are 75. Next, if you would go, is 15 times 6. So that gives you the answer as 90. Okay. So between 75 and 90, you would not get 85. So this is not a multiple of 15. This is not. Now 60. 15 times 4 if you would do. Okay. So 5 fours are 20, 0, 2 carried over. And 4 ones are 4, 4 plus 2 is 6. So this gives you the answer as 60. So this also is a multiple of 15. So basically, which are all were the multiples of 15? 45, 75, and 60. We went through the multiplication table method. Also, like you can do the division though. So here comes the next quick question for you all, and that is, which of the following are the factors of 72? Again, I will be giving you some options. You can choose from those and tell me what are all the answers for that question. Okay, so you have options as 2, 4, 6, 9. Out of these, which are all the multiples of 72? Sorry, the factors of 72. Yeah, so the factors, you need to find which are all the factors of 72. They might be 1, 2, 3, all, anything. How would you do it? You need to do the division. If you get the remainder as 0, then that means the given number is a factor of 72. So we'll start with the first one, 72 divided by 2. So any which as you see that 72 is an even number and 2 would definitely be dividing it, but we'll just go through the division. So 2 3s are 6, 1 left, you take down 2, and 6 are 12. So yes, it is. We would go with the division of 72 by 4. So 4 ones are 4, 4 twos are 8, so you would go in with 4, left with 3, take down 2, 8s are 32. So yes, this also is a factor of 72, going with 6. So 72, 6 ones are 6, you're left with 1, 2 taken down, 2s are 12, you get the remainder 0. This also is a factor of 72. And let's see, 9. So this also, is quite easy, but just by looking at it. But for all of you who do not know the multiplication table of 9, 9 was a 9, 9 was, you go on like this, and 9 eights are 72. You get the remainder as 0. So all of these are the factors of 72. So all are the correct answers. You couldn't have left any of these. So I hope you all so far are very, very clear and thorough with what factors, multiples, primes are and how to solve these problems. Very basic and core problems, but I think this is what builds the foundation of learning more properties of these concepts. Now, these are all, the classes that we're conducting are live sessions wherein, it's just me with all of you students, and I might not be able to pick up all your doubts. But what you all can do is book yourself a free trial class. That will be a 101 class. That means there will be just you and one teacher. So that means that expert teacher is dedicatedly for you, who would be clearing all your doubts. And as many times as you want to ask, how much ever you want to ask, you can ask the teacher. And that class is just exclusively for you. So you have all these free trial classes that you can opt for. You would be working on some interactive worksheets. When we say interactive, they are loaded with simulations. You will be able to visualize all of this. What factors, multiples are. There will be so many simulations. It's loaded with simulations, and also you will be solving some puzzles. So, whenever you feel that you're free during the week or during the weekend, whichever time you're free in, you can book yourself this 101 free trial class with an expert teacher and working on some interesting, fun, and simulation loaded worksheets. So here's the link that you see on your screen. You can click on this link and it will take you to the page. You'll land on the page which is shown on the right side of the screen, and these are some simple steps that you can see on the left side of the screen. All you need to do is fill up some basic details, select the time and date for your class, and it's done. So all you need to do is to click on the link given on the page. You can copy that link and it will also be shared in the chat box. So you land on this page. All you need to do again is to fill up some basics, some basic details about you and your phone number and all, and select the time and date that you're free in, and your class is booked. So with that's a wrap for today's live session. We'll be winding it up here. Thank you all for joining us. Make sure that you book yourself a free trial class and experience an amazing session. I will see you all again in the next live session. Till then, take care. Bye-bye. See you all.